Hey everyone, welcome back. Hope you enjoyed the Epstein and Skinner presentation. I wanted to point out that the Columban Simulation Project, as well as the next session we're about to do, session 25 on stimulus equivalence relations, both of these topics are treated in the Pearson-Cheney verbal behavior chapters, so you could always refer back to that to take a look and see anything you might have missed, either in the lesson on the that we're about to go through now, or in the actual videotape. Actually, I thought that the presentation served better than the book, because in the book, which is black and white, they kind of explained Jack and Jill's study having to use features such as triangle, circle, and so on, because they didn't have the actual color. So it was kind of cool probably to see Jack and Jill doing those sorts of things. And also, a picture is worth 1,000 words, right? It was also interesting when I moved to Boston, by the way, not only working with Robert Epstein, but Sidman actually had some involvement, a great deal of involvement in the early workings of the Cambridge Center for Behavioral Studies. So I had a chance to actually meet and get well acquainted with Murray Sidman and his wife Rita. Wonderful, wonderful people. And I got a chance to see a lot of the research in its development, going from the mediated transfer stuff that he was starting to study back in the days when he was working with brain injury, and then actually seeing it take off in terms of the technology and the sophistication and the experimental questions and the formulations of really, really interesting ideas about where verbal language comes from, and more in particular, concept formation, a different way to look at it. So this is really a lot of great research on conditional discriminations. By the way, conditional discriminations are also discussed in that same chapter in verbal behavior in the Pearson-Cheney book. So I wanted to spend a little time and actually treat stimulus equivalence in its own right as a topic matter, and point out, actually, if anybody's interested, I pointed out in one of the other sessions, Sidman's book called Coercion and Its Fallout. This is actually another book by Sidman called Equivalence, Relations, and Behavior, a Research Story. If you're ever interested in learning about this topic, this is an incredible book. It's a very big book, but it's one of the ways in which you really get an appreciation for scientific writing, because there's a lot of great information in here that Sidman takes you through literally in first person. He's writing to the audience as if he's explaining to you the whole story about where this stuff came from. It's a very easy and fun read, actually, to follow the thinking about him, from him and the group of researchers that he was working with. So again, it's a very personal approach to reading a lot of information about stimulus equivalence. So recommend it. Let me go ahead and freeze the camera. Excuse me. All right, and I got my trusty pointer here, and let's go ahead and get started. So Sidman and his work in stimulus equivalence actually has early start when he was doing work with aphasic patients who had brain injury. And some of these patients, actually, you find out, are patients that you might have read about in cognitive psychology, some very, very famous studies about people who had a lot of seizure disorders, one person who had a pipe through his head, and so forth and so on. He did a lot of research with patients who had these kinds of brain injuries, and found that the patients that he was working with, they were aphasic, and that these patients could not speak or write intelligibly, and he needed to come up with a device to investigate this language comprehension without requiring them to speak or write. And that's where he actually, in discovering this stuff about stimulus equivalence, he was able to find that through his arrangement of controlling the variables through this tabletop activity, that he could find the origin of where these language variables came from, how patients who were aphasic, who could not speak or write, but could actually still put together concepts. And that's what we're going to kind of go through here, where some of this research led to. Not necessarily the specific work he did with these patients, although if anybody's interested, I have a fairly extensive collection of this early research by Sidman and his colleagues, Sidman and Stoddard and many others. What I want to kind of go through is the actual conceptualization of stimulus. So, if we go back to the very beginning of when we talked about behavior, operant behavior reinforcement, we were actually talking about a two-term contingency. That is a two-term contingency. The first term is the response and the reinforcer. You have operant behavior and reinforcer. And when you have the response and the reinforcer placed under particular stimulus control, what we say discriminative control, we are talking about what is called a three-term contingency. Remember the SD, the behavior, and the consequent event, in this case a reinforcer, a three-term contingency. And this clearly happens when we press a response here and we get a coin, right? We press a button and get a coin. And if we do any other behavior that doesn't lead to getting the coin, you'll see here the line here, right? We don't get a coin. So this is a simple two-term operant contingency. Press, get coin. Do anything else except press, you won't get a coin. When we take this condition and place it under a contingency, a stimulus contingency, such as here, we could say that in the presence of a square, if you press this square over here, you get a coin. Anything else you do, you don't get a coin. And we could also make sure that it comes under good stimulus control in the sense that when we put a circle up there, the same thing holds true. In the presence of a circle, no response, including pressing that original space on the wall, will get you that coin. In other words, when you have an arrangement like this, the organism learns very quickly only when the square is present do you make that specific response, do you get that specific consequence. And therein lies the three-term contingency. This should be nothing new to you folks, right? Right, okay. What might be new to you is something called contextual control. And contextual control happens when the three-term contingency is placed under conditional control. Again, this stuff is treated very extensively in the Pearson-Cheney chapter, but I just, again, want to kind of introduce you to the idea here of what we call contextual control, okay, or we call the formation of a conditional discrimination. And the fundamental unit of a conditional or instructional control is what's called a four-term contingency. And this results in a very different kind of stimulus control. Okay? This happens in this situation. If we see a square, and in the presence of square, we learn in the three-term contingency, right, that I just showed you before, square, make this response, you'll get a coin. In the presence of circle, you won't get anything. Okay? And also, in the presence of square, anything else you do but this particular response will not get reinforced. So here in the situation, we have a very tight discrimination, three-term contingency, right? But now we could take this whole contingency here and place this under another contingency. In other words, when a green light is on, that means that the square results in pressing this and getting a coin. We could also teach that in the presence of a red light, these conditions reverse. That is, when a red light comes on, the square no longer results in anything. Nothing you could do. The original response or another response will not produce a coin. And now, when the circle is present, right, when you make a response, you get a reinforcer. Now, actually, what should be going on here for the four-term contingency, and I don't know why this isn't here, is that what you should have is this should not have a bar right there, right? Because what you're learning here is that in the presence of green, square results in a coin. In the presence of red, circle, make that response, get the coin. So actually, this is probably a typo. Isn't that interesting? I have to make a note of that. Oh well, let's move on. All right. So under these conditions, what happens here, and this, by the way, I hope really helps. It took me a while to get these things here, so that it keeps this stuff straight. If you are reading the book and you're saying, let's see, triangle means vertical line, but circle means a horizontal line, but that only works when this color is light, and when this is dark, everything reverses. That becomes a little bit difficult to understand. So I'm hoping that my presentation is a little bit better than Pearson-Cheney. Okay, so here we go. If green, press square, produce consequence. Right? If red, press circle, produce consequence. In this situation, the green hue and the square, become equivalent members of one class. And red hue and circle become equivalent members of another class. That's what we're talking about when we call it a conditional discrimination. That it's conditional. Square works only when this happens. Circle works only when this happens. So circle is conditional on this arrangement and square is conditional on this arrangement. And then we have what we say the formation of if this, then that. This is how we state contingencies, if-then statements. Okay? All right. So when we talk about equivalent relations, these things emerge when the following conditions are met, or the properties are met. The first one we're going to talk about is reflexivity, and they treat this in the book, again, in terms of identity matching, or what they call generalized identity matching. That is, in this situation, stimuli must be conditionally related to themselves. So here's how this works. Reflexivity means is that we have to start somewhere. And before you could shape up something like this, see green, press square, get reinforced, see red, press circle, and again ignore this because this is wrong, press circle, make that response, and do get reinforced. In order to set up a conditional discrimination, this just doesn't come out of thin air. You have to actually do a couple of things first. And the place to start is this idea of reflexivity. You got to first be able to have a square show, that is, a square is presented as a sample, and the subject presses square and lights up one of two things here, a square or a circle. So what you have to be able to shape up is, in the presence of square, see square, press square, and get reinforced. Okay? In the presence of circle, press circle, right? Get reinforced. Right? Now, the same thing has to hold true here with green. See green, press green, reinforcement. Okay? Red, press red, reinforcement. Now what happens here is that you actually do identity matching and you teach one particular thing. You put one thing in the center of the screen, you press that, and then you teach one particular response. And what's interesting here in terms of what we call generalized matching is that once you teach reflexivity for one particular thing, you start getting generalized reflexivity. That is, once the animal learns the sequence of sample comparison and being able to learn sample comparison, they should automatically start doing it with circle to circle. Oh, let me get there. Circle to circle, green to green, and red to red, just by teaching square to square. That's pretty remarkable. Because again, one of the things I want to point out about this research, as well as Epstein and Skinner's research, and the point they're trying to make is that new behavior is emerging without conspicuous, obvious reinforcement. As I mentioned to you before, one of the obvious criticisms that we hear from psychologists, and in particularly linguists, is that reinforcement theory always accounts for behavior because it's conspicuous, behavior reinforcement. And when you show that relationship, everybody could see it and it's conspicuous. But when it comes to seeing a behavior emerge in which reinforcement did not take place, how could you rely on reinforcement theory to explain something where there was no reinforcement? So again, in the Epstein and Skinner experiment, they showed you that even though they didn't reinforce the emergence of memoranda use, insight, and also the other experiment of self-awareness, what they called self-awareness, they actually taught pieces of behavior that actually came together in predictable sorts of ways. And the same thing you're going to see here holds true. If you teach these relations, then you're going to get reflexivity in terms of generalized identity matching, in which you get this response. And again, the asterisk here shows you is that during reflexivity testing, they are teaching this, but there is no coin that is delivered when you're testing for reflexivity. And again, these behaviors will emerge without conspicuous reinforcement. So now we actually are able to teach this response, but now let's actually look at a real-life example. Let's look at a condition of a conditional discrimination. We see the number 2, And now we press the number sample in front of us, a lit key that has the number 2. That goes dark, and then 2 keys light up. On the left side is a key that says TWO. On the right side is a key that says SIX. The response to 2 should be TWO. Press that and get reinforced. That's the contingency of reinforcement. And here's another conditional discrimination, the number 6. See that as a sample, press that, and then that lights up 2 comparison keys, TWO and SIX, like up here. But in the presence of this, press this, right? And then you're going to get reinforced. This is a conditional discrimination. And so this shows you a real-life example. Where does this come from? Okay. So again, it's obvious that to teach this, you're going to have to be able to teach a couple of things here. Actually, let me go back and show you something here. It stands to reason that if you're going to teach a child to do this, the starting point is not to show them 2 and go to TWO. You probably want to do some identity matching. 2, see the 2 and go to the number 2 versus the number 6. You might have the sample, see the number 6, and then have a comparison of a number 6 and a number 2. In other words, before you can get to this phase, you're going to have to do identity matching and teach the number 2 to the number 2, the number 6 to the number 6, TWO to TWO, SIX to SIX. And by the way, we do this all the time with kids. This is really one of the starting points. And we teach identity matching as a very first starting point. Now we're going to talk about something called symmetry. This is a second sort of feature. This is a conditional relation which must hold true if the sample and comparison are interchanged. It's the reversibility of condition. In other words, we say that if the upper condition holds true, the bottom condition must hold true, even if that person has never experienced the contingency. So what does this look like? Well, let's go back to this example. Once we have taught identity matching to a child, that is, right, number to number, word to word, the number 2 to number 2, the number 6 to number 6, etc., now we're ready to do the next phase of teaching. If we show the number 2, we reinforce to TWO. Okay? We reinforce to TWO. And we establish this conditional relationship. Okay? Now in this instance, we're also going to teach the next part of the conditional discrimination. See the number 6, and now we're going to give again the word. So again, in all of these conditions, if we teach this to this, right, get reinforced, and then we teach 6, oh, come on here, 6 to SIX, boom, do that, get reinforced, and this is the teaching. Now we should actually do the symmetry test. Remember, in the test condition, we do not reinforce. So even though you see here that this condition leads to a coin, you see the asterisk here, if we teach this and this, then we do the test. We do not provide reinforcement in these conditions. And what you're showing here is that this is what you teach, sample and comparison, the numbers, the sample, the words, the comparison. In the test, they see a completely novel stimulus. It's the first time they see the word as the sample and the number as the comparison. So that not only do we have a novel stimulus situation, right? Number, now it's a word, they've never seen that before, and they actually are able to successfully reverse the condition without conspicuous reinforcement. This is what we say is symmetry. If this holds true, if A equals B, then B must equal A. Okay? The third feature that we're going to talk about is transitivity. Now, some of you may remember something in school called transitive property. If A equals B and B equals C, therefore A equals C. And if we are able to apply the rule of A equals B, B equals C, and A equals C, and combine that with symmetry, then if this is true, then C must also equal A. This is what's called transitivity. It's the emergence of a new response to a contingency that has not been, and here's the key thing here, explicitly instructed. That's the key. Okay? And here's the example. Again, the book goes through this, but maybe this makes it a little bit clearer. A equals B. We teach this, right? We present the sample 2, respond TWO, reinforcement. Teach that response. We teach the response sample 6, Word 6 is the comparison. Make that response get reinforced. So we teach this conditional relation, right? Now we're going to introduce a new conditional relationship, a new set of stimuli. In other words, we may introduce the quantity of two x's, or two balls, or two things. Okay, so now we teach the response TWO. So here we have A equals B, A equals C, right? Now we're going to go the word to the quantity, teach that, reinforce that. 6, the word to the quantity, teach that. And now when we teach this and this, we test for transitivity. In this condition, once again, we do not provide reinforcement. You see the asterisk here. And in this condition, you are presenting two sets of stimuli that the person has never seen before. A and C. They have seen A, but only in relation to B. They've only seen C in relationship to B. Here we have A equals C. And when you shape this, and you shape this, and test for this, you get this response to emerge, which shows and demonstrates the property of transitivity. Okay, that is 2 now will lead to quantity of 2, 6 will lead to SIX. And again, if A equals B and B equals C, A equals C. Now we're going to actually show here also an example of C equals A, right? A equals B, B equals C, and C equals what? A. And what's interesting here is that not only is this a novel arrangement, but this is a situation which is really novel, because not only in this situation are we pairing A with C, but in this new situation, they've never had a chance to see the quantity C as a sample, okay? And they've never seen the number 2 as a comparison, and yet it still emerges. That is remarkable. And the thing that's interesting here is that not only are we getting this without conspicuous reinforcement, but we're also finding inconspicuous sources of stimulus control. That is, we are now learning where some of these behaviors come from and why we get certain things become equivalent members of classes at some times, and at other times they don't. So let's go through some of the summaries here that Sidman made. First of all, according to Sidman, when conditional relations possess these 3 properties of equivalent relations, the stimuli that are related to each other become members of a class. Okay? That is, there is a formation of stimulus classes that allows us to say that the number 6, the name 6 have the same meaning, or that each one means the other. In other words, this is semantic correspondence, and it emerges from a non-linguistic if-then relationship. Okay? In other words, these are not rules that we formulate. This is actually the emergence of stimulus control, and the control happens outside the organism, not inside the organism. Okay? And that's not to say, by the way, that there are not important things that are happening here in terms of neuroanatomy. In your book, I really invite you to read carefully the analysis of brain function with stimulus equivalence relations. It shows you that when these things are actually happening in human subjects and they are put under functional MRIs, we are seeing that these behaviors are actually lighting up particular areas of the brain, in particular the right frontal hemispheres, which is something that becomes very interesting to us, in particular if we work with individuals, adults and children with autism and with pervasive developmental disabilities, because part of that are language problems. We know that the right frontal lobe is very much implicated in Asperger's and many other kinds of non-language kinds of verbal learning disorders. Okay, so again, when we are looking at these sorts of things, it becomes interesting that we see that when these things come together, we are seeing activation in parts of the brain, so that we know, number one, what parts of the brain are important, but more importantly, we're actually finding how the environment needs to be arranged for these behaviors to come about. We certainly know that if you can't get a person to do identity matching or symmetry, you will not be able to get them to do transitivity. On the other hand, if you teach those two things, identity matching and you teach symmetry, now you get transitivity. And this is exactly what Sidman was showing in his early research in the 50s and 60s with brain-injured patients. These are patients who they really believed had complete aphasia. But what he did was actually to go back and reshape these verbal relations, and he was able to get them to do things that they weren't able to do before. Okay? All right. Now, we could go so far as to come up with something called a 5-term contingency. Now, when it comes to this stuff, put on your safety belts and get ready, because this gets pretty complex. But I'm going to walk you through it anyway, because this research has really taken such an incredible turn in a wonderful direction, and looking at things that are just unimaginable that can actually be analyzed today. In other words, we take the 4-term contingency and place this under yet a 5th-term contingency. So I'm going to walk you through this, and if you get confused, don't worry about it. At the very least, it's not on the exam. But I really want to show you a really exciting area of research right now. The 5-term contingency is the unit of second-order conditional control, and it describes the influence which the environment exerts over a conditional discrimination. That is, once a conditional discrimination happens, the environment could take that and place that under further stimulus control. Okay? 5-term contingency leaves discriminative control untouched and accounts for variations in relations between conditional and discriminative stimuli. So whereas the 4-term unit makes stimulus control of behavior more flexible, the 5-term unit makes conditional control of stimulus control more flexible. Ooh, that's a mouthful, huh? In other words, here's what happens. Here's that conditional discrimination. The presence of green, that press square, get reinforced. Again, in the presence of red, press circle, get reinforced. However, what you have here is that this condition only holds when a certain tone is on. When another tone comes on, the conditions change so that now green controls circle and gets reinforced, and red controls square and gets reinforced. In other words, these conditional discriminations hold true when this holds true, red and green, only when this is happening. When that's happening, everything reverses. So you could start seeing here where you could have a 5-term contingency, a 6-term contingency, and so forth and so on. And holy moly, how does one keep track of all of that? Well, here's the thing. It happens. It actually does happen. So here's what's going on in that picture. Now, when you look at the sort of thing, hang on, don't freak out here. Actually, it sort of looks like chiclets. Green and red and blue and purple. Anyway, here's what to say. With the 5-term contingency, we could still say green and square and red and circle, red means circle, but only in the presence of tone 1. When tone 2 is present, the meanings change to green means circle and red means square. Sometimes square and green are equivalent members of one class, and this circle, I guess, moves. And sometimes circle and red are members of another. But at different times, one class includes square and reds as equivalent members, and another includes circle and green as equivalent members. Sorry, this moved. I don't know why this happens on your PowerPoint presentation, probably that you got off of the website, off of the learning thing. It probably came out clearer. Somehow, when I transferred this over to Adobe Contact, it doesn't like my slides that much. What could I say? I apologize for that. Anyway, so what happens here is that without contextual control by tone 1 and tone 2, common elements of the 4 classes, square and green, red and square, and red and circle, and red and green, would all cause the hues and forms to combine into a single large class and totally become meaningless. The way I get this, and a good way to interpret this, is that if you go back and look at this, that if this kept happening again and again and again, all of a sudden certain things would just collapse upon itself. Everything would actually be the same as everything else. So in other words, in real life, the 5-term contingency in operation works like this. And let's look at this quote here from Sidman. Mercury can be considered as a metal and a liquid. Now, in chemistry, or perhaps if you've ever, broken a thermometer, you kind of had the opportunity to play with mercury, which is not. My mother used to tell me that you shouldn't play with that. But how can you help it? Man, it It's metal and it's liquid. It's liquid and it's metal. It's so cool that it was in Terminator 2. I mean, that's what made Terminator 2 so cool, that new liquid metal stuff. Man, that's neat stuff. So when you break a thermometer, of course you're going to play with that. And it does have property as a metal and as a liquid. On the other hand, it's not a metal and it's not a liquid. How do we deal with that kind of stuff? Well, here's the contextual control. This is the 5-term contingency in operation. We place this under contextual control by giving the 5th term contingency. This word or this sentence is very much like tone 1 and tone 2. Today's topic is oxidation or flow of patterns. Okay? This prevents other members of the class metal from entering into equivalent relations with members of the class liquid. Mercury can therefore sometimes be equivalent to an iron and sometimes to water without making those two elements equivalent to each other. Okay? So, when we look at real life, we see a lot of contextual control all around us. When we ask for favors of certain individuals, we may or may not get reinforced. So we certainly see SDs. A child sees mom and sees dad and wants to ask for a favor. He or she could ask mom, or he or she could ask dad, but why does he go to one or the other? Right? If my daughter wants to ask me for something, she's very good at looking at contextual control over my behavior. If I'm watching a Florida Gator football game and it's the 4th quarter and things are not going well for the Gators, that's usually an S delta. But at the same time, it's contextual control that perhaps she may actually now, in the presence of this stimulus, which is less likely, it might raise the probability that other conditions of going to mom might actually be reinforced and so on. So there are conditions that you could say, I could go to this person and that person. There are clear SDs, but there are other things in the environment that certainly give rise and strengthen and change and alter the control of those SDs. That's the contextual control that we talk about. Okay? Again, this is a really, really exciting area of research, and I want to make sure that we spend time talking a little bit more about this. Again, I would encourage you to read this material carefully in your books. There are very few questions, I think, on the exams, but again, if you do go to the Association for Behavior Analysis or similar conferences, I really encourage you to attend the tutorials on this particular area of research. It's wonderful. There are great researchers in this field, Katie Saunders and Richard Saunders and Joanne Clideris and Carol Pilgrim. These folks are really eager to teach you folks about how these things work, because these become so important in language acquisition to many of the individuals that we're working with. So we will stop here.